direction. So for general references towards the right side, whatever measurements we make towards the right, we take them to be the positive directions. And whatever directions are towards the left, we take them to be the negative directions. But it's not a mandatory. We can choose the left direction to be the positive and right direction to be the negative. We can choose it that way also. Got it? So here, uh, whenever you are talking of the direction, you will say the positive direction and the negative direction. Okay. And on this basis, we had found out a quantity, we had found out the change of momentum. We had seen how to find out the change of momentum. So, Harshit, how do we find out the change of momentum?
So change of momentum is equals to final momentum minus initial momentum.
Yes, very good. We obtain it by subtracting final momentum. We obtain final momentum minus initial momentum. Okay. So this way we obtain the change of momentum, which can be obtained as final momentum minus the initial momentum. And we had seen here certain examples. We had done some questions for the change of momentum. So I would like to do one more question for the change of momentum. See, I'm writing your question. Just try to solve the question here. So a ball of mass 150 gram is moving with 90 kilometer per hour. The batsman hits back and the ball moves retrace back with a speed of 120 kilometer per hour. So you have to find the change of momentum. Okay. So find the change of momentum. Can you find it? You have a ball of mass 150 gram. It is moving with 90 kilometer per hour. The batsman hits back. The ball retraces back with a speed of 120 kilometer per hour. Find the change of momentum. So it's something like this. From here, the batsman hits it. Let this be the direction in which the ball is coming towards the batsman. So here, the ball comes towards the batsman like this. Okay. The ball itself has a mass m given by 150 gram and its speed u is equal to 90 kilometer per hour. Okay. Now, when it bounces back from the or when the batsman hits it, so after being hit by the batsman, the ball retraces back in the opposite direction with a speed of 120 kilometer per hour. Okay. So Harshit, Pranav,
Yes, sir.
yeah. So are you doing the question?
Yes, sir.
Okay. So come on. I'll wait for 2 minutes and then I'll give you the answer. So all of you have to take care of your units. Whatever answers you obtain, you just send it as a direct message to me. Okay, anyone got the answer? I didn't get anyone's answer. Yukta? Yukta, are you there? Okay. Okay. Have you got the answer? No one got the answer up to now.
So,
Okay.
step.
Uh,
So, one
Jitendra?
second.
Sir, 1 minute, sir. I must.
I'm still doing, sir.
So, I
You are
got the
still
answer
doing.
1200 gram meter per second.
So convert this gram to kilogram. Use always SI system of unit. So you are taking one of them in CGS and one of them in SI. Convert it in the SI system of unit.
So, 1.2 kg meter per second.
So let's see. First we convert this initial velocity 90 kilometer per hour. So this initial velocity, and also we take here the directions. So we are taking the right direction to be the positive direction and left direction to be the negative direction. So in this way, here the initial velocity would be 90 times of 5 over 18. So this you get 25 meter per second. You get 25 meter per second as the initial velocity. And since it is towards the right direction, so we write it plus 25. The second velocity is 120 kilometer per hour. We convert this 120 multiplied by 5 over 18. And here we get something 100 over 3. So this is 100 over 3. That is roughly 33.3 meter per second. Right? So you have the final velocity as 33.3 meter per second, but this velocity is in the negative direction. So we take it as negative 33. This velocity is negative 33, and hence the change of momentum will be taking as the final momentum minus the initial momentum. So change of momentum, which we denote as delta P, delta P means change of momentum, will be equal to final momentum, which will be 0.15 mass taken in kilogram, multiply with 33.3 minus again 0.15 multiply with 25. Again taking care of the sign. So this 33.3 was negative. So this whole term becomes negative, or you put a negative over here, negative 33.5. So your finally your answer will be minus 0.15 multiplied with 33.3 plus 25. Okay. So you add them and then multiply by 0.15. That will be the change of momentum. Okay. So let's see. So you have 33. 0.3 plus 25 this, and you have to multiply this by 0.15. Okay. So is this the answer you are getting? 8.745. Anyone got this answer? 8.745.
Sir, I got,
Yes.
sir. Sir, I got.
Okay. So just one person got this answer as negative of 8.745 kilogram meter per second. Okay. What was the mistake with other people? Jitendra, Yukta, where did you go wrong?
Sir, I did the multiplication wrong.
Okay, you did the multiplication wrong. So mainly you are having your computational mistakes.
Yes, sir, a bit.
Okay. So try the computational mistakes will go away with practice only. Otherwise, I think everyone has understood how to obtain the change of momentum. Okay. Now the next one is the fourth. Next one is the second law of motion. So before going to the second law of motion, can anyone give me an idea of the first law of motion? Yes. Can anyone give an idea of the first law of motion? What is the first law of motion? Yes. What will be the first law of motion?
Sir, the first law of motion states that any object that is in the state of rest or in state of uniform motion will remain in its state until and unless any external unbalanced force is applied on it.
So according to the first every object every body will continue in the state of rest or of uniform motion a straight line unless acted upon by an external unbalanced force. So unless there is an external unbalanced force, so every body will continue in its state. It will remain in its state. That means if it is stationary, so it will remain stationary. And if the object is moving in a straight line, so it will continue to move in the straight line with the constant speed with the same speed. So the object will continue to move with the same speed unless acted upon by an external unbalanced force. So what do we again here we need to understand that before moving on to the second law of motion, we need to understand external forces, unbalanced forces, and internal force. These terms we have to understand. And I think I had given you an example of an external force and unbalanced forces also. Okay. So can anyone give me an example of an internal force? What forces can be the internal forces? Yes, can anyone give me any example of internal force?
No, sir, I don't know.
Okay, so shall I give you an idea? Any, and maybe after that you will be able to think of it. Okay.
Okay.
Suppose if you are sitting in a bus and you are trying to push the bus, or if you are sitting in a car and trying to push the car by pushing your front seat. So, are you applying any force?
No.
You are not applying any force. When you are pushing the seat, you are pushing the front seat, you are not applying any force. Yes, you are applying a force over there. You can't say you are not applying, because force means a push or a pull. So you are applying a force on it. Okay. But that force will not cause or will not bring about any change of motion in the car. The reason being, the force you are interacting with, you are a part of the car. When you are sitting in the car, you are a part of the car, and the forces which you are applying, they will be called as the internal forces of the system. Okay, so the force applied by you is an internal force of the system. Got it? Can anyone give any idea, any other example? Okay, so see, the amount of force acting on an object is directly proportional to the rate of change of momentum. This is the statement for the second law of motion. So here we have just cleared a meaning of external forces. So what are external forces? Yes, Muhammad Rayan. Muhammad Rayan.
Yes, sir. Yes.
Okay. So what are external forces?
Anything like the force of gravity push.
The force which acts outside the body or from the outside of a body is an
Yes.
external force. Okay. For example, if you consider the car and the force of friction. So the force of friction is not a part of the car. It is a part away from the car. It is a part not included in the system of car. Okay. So the frictional force acting on the car is an external force. Got it? Whereas the force acting when you are pushing the car, sitting in the inside the car, that is an internal force. Okay. You are trying to bring down the glass or window of open up the window. You are trying to break open the window. So that is the internal force. Okay. Got it? What are internal and external forces? Yukta?
Yes, sir.
Okay. So I will ask you everyone. Everyone has understood about, everyone knows about the bomb blast, how a bomb blast takes place. So during a bomb
Yes.
blast, okay, so during an explosion, what are the forces? Are they internal forces or external forces?
Sir, internal.
Internal. Exerted, the forces exerted by the explosive are the internal forces of the bomb. They are the internal forces of the bomb. we are not applying any external force on the bomb. Okay, so whatever forces we are applying, or whatever forces are being applied on that bomb, they are just the internal forces. They are the forces which we are getting due to the excessive heating or due to the explosion that is occurring inside the bomb. Okay, so those forces, they are all internal forces. Got it? It's something like that. Suppose if you are sitting in an aeroplane. Okay, so if you are sitting in an aeroplane and you throw a heavy object on the aeroplane to the either side, so your force, whatever force you are exerting by throwing an object or whatever, all those forces, they are internal forces inside that aeroplane. Again, see this example: a person rowing a boat. So what forces is the person applying on the river? Is it an internal force or an external force?
Sir, internal.
No. When the person is applying the force, he is not pushing the boat, he is pushing the water. Okay, so however, he is inside the boat, but he is applying the force on an external object. Okay, so the forces applied by a person rowing a boat, it is an external force and not an internal force. Got it? However, he is sitting inside it. It's just like uh, you are suppose sitting in your car at the driver's seat with one leg inside the car and one leg outside, and then trying to push the car with one of the legs. So in that case, you are applying your force on the earth. So that is an external force for the earth. Have you understood the meaning of the external and internal forces? Internal forces are the forces acted within the system and on the particles within the system, by the particles within the system and on the particles within the system. So it's something like this. Suppose if you have a system of particles, you have a system of particles like this. It consists of a number of particles here. Now, each of the particle, consider each particle. Suppose this particle exerting a force on this, exerting a force on this particle exerting force on this, here. So the particles, they are exerting a force on each other. So these forces, they are all internal forces. They are not external forces. The particles which are acting within this system, they are all internal forces. But so here, if I call these forces, so they are all internal forces. The internal forces cannot bring about any change in the state of motion. Okay, it is the external force which will bring about a change in the state of motion. So let's say what's an external force. So if you are applying some force over here, suppose you tie it with a thread and you apply some force. So if you are applying some force F over here, so this force is now an external force. Got it? Understood this? External forces. The forces applied by the particles outside the system. If forces are applied by the particles outside the system, so they are the external forces. Okay. Then what are balanced and unbalanced forces? Pranav, what are balanced and unbalanced forces? Pranav, what are balanced and unbalanced forces? Pranav, are you there? Pranav, are you there? Sampath, are you there? Pranav, Sampath.
Yes, sir.
Okay, so Pranav is not here, right?
Maybe.
Yeah, Pranav. Pranav. Yeah, Jitendra, what happened?
So can I tell?
Yeah.
So in balance forces,
Mhm.
net force is zero, sir.
Yeah.
And in unbalanced forces, net
Mhm.
net force is not equal.
Yeah. Net force is not zero or non-zero. Okay. So if we have the sum of all the forces, the sum of all the forces equated to zero, if the sum of all the forces becomes zero, then we say that the forces are balanced. And if the sum of all the forces is not equal to zero, then the forces are unbalanced. So when we say that the forces are balanced and unbalanced, when the sum of all the forces is equal to zero, then we say that the forces are balanced. And if the sum of all forces is not zero, then the forces are unbalanced. So see, we'll observe each and every point here. So consider here an object. Let's say you have a ball or any object, and consider two objects or two people trying to pull it in opposite directions. So you have here two people trying to pull in opposite directions with the same force. So if two people they are trying to pull in opposite directions with the same force, so in this situation I will say that the net force on the object is equal to zero. Here we have net force equal to zero, and hence the forces are balanced. Hence here we observe that the forces are balanced. Got it? And hence there will not be any change of momentum. As we are stating in the statement of the second law of motion, the amount of force acting on an object is directly proportional to the rate of change of momentum. So from the second law of motion, we can write like this. From second law of motion, we have the force being directly proportional to the rate of change of momentum. The symbol which I have put here, this symbol is the symbol for proportionality. Okay. So as you have studied directly proportional and inversely proportional. Okay. In your mathematics grade 8, you must have studied about the change about direct variation and inverse variation. Right. So Harshit, what is a direct variation?
Sir, which is directly proportional to the
So what things we expect when we say some quantity is directly proportional? So what is expected out of it? Can you give any example of a quantity of quantities which are directly proportional to each other?
so 1 minute.
Yukta, can you give any example of the quantities which are directly proportional to each other? No one? Okay, just see your revise your mathematics. When we say the amount of quantities you buy and the amount of money you pay, okay, like number of people traveling and the cost. See, is it directly related? You have number of people that are traveling, and you have here the amount that you have to pay, amount of ticket. So is it directly proportional? More the number of people,
Yes, sir.
more the amount you have to pay. So it is directly proportional. In the same way, here we say that the force is directly proportional to the rate of change of momentum. That means the greater the force, greater will be the change of momentum. Okay. So we can write it as F proportional to change of momentum. So change of momentum is given by final momentum minus initial momentum, as we have already seen, change of momentum per unit time. So change of momentum by time will be force. So I'll write it as force proportional to change of momentum, which is final momentum mv minus initial momentum mu divided by time t. Okay. So since mass is constant throughout this relation, we can take out mass constant and we can write F proportional to m multiply with v minus u over t. So what is this v minus u over t? Yukta, Mohammad Rayan,
Yes, sir.
Rayan,
Yes.
what is this v minus u over t?
It is the formula for
Yeah,
uh
it is the formula
the law of motion, like the initial
acceleration.
velocity acceleration, the initial velocity minus final velocity. Like,
Final minus initial by time, that is
yes.
acceleration. So we can write it F proportional to mass times acceleration. And finally, obtaining the constant of proportionality. The constant of proportionality between force and this is found to be 1. And hence we write it F equals to the constant K multiply MA. When MA is measured in SI units, so the constant of proportionality is 1. And we can write it as F to be equal to MA. So here the value of K or constant of proportionality is equal to 1. Got it? So we'll continue in the next class from here. But from up to here, you should be clear that we have force as rate of change of momentum. And the formula of force is mass times acceleration. Okay. So bye all of you. Take care and see you again in next class.